Hello, everyone, and welcome to another Applying Ethology webinar. I'm Laura Whalen, and together with Jen-Yan Chow, Christian Naroth, and Sebastian Gumon, we organize these webinars in the Animal Welfare Slack workspace. As we begin today, I want to remind you all to please turn off your camera and microphone. Should you have questions for our speaker, please type them into the chat box, and we will address them at the end of the presentation. It is my pleasure to introduce Madalina Mincu, a PhD candidate who is recently completed at the Research and Development Institute for Bovine Balotasti in Romania and the University of Agronomic Sciences and Veterinary Medicine. Today, Madalina will share the main findings from her doctoral thesis, where she has explored the effects of behavioral reactivity on production, reproduction, health, and welfare of dairy cattle and water buffalo. Welcome, Madalina.
Hi, everyone. Thank you, Laura, for the introduction. Can I share my screen?
Yep, you should be able to.
Yes, thank you. Can you see my presentation?
Yes, and it's in presentation mode.
Yes, and if it's okay with you, I will start, or should we wait another minute?
Please go for it.
Thank you. So, hi, everyone. Thanks for being here. Today, I will present my PhD thesis entitled Effects of Behavioral Activity on Production, Reproduction, Health and Welfare in Large Ruminants. My presentation for today consists of 4 parts. I have just 2 or 3 slides about the Romanian dairy sector, an outlook about the behavioral activity and temperament, my research all about, and some ongoing studies which I began working during my PhD. So we have around 1 million cows, 35% dairy, 10% beef, more than 50% dual purpose, small farms predominantly, more than 30% of the farms have more than 50 heads, and the dairy products consumption is 258 liters per capita. For the breed structure, we have the Romanian spotted, the Romanian Holstein, and the Romanian brown. Sire selection, we have 2 national bull station, 60% internal consumption. Performers recording and bull testing costs 70% subsidized by the state. Salmon imports from Germany, Austria, Switzerland, Canada, and the USA, and the genomic selection was recently introduced. For dairy water buffalo, we have 18,000 breeding buffalo cows, down from 600,000, around 1,700 kilograms of milk per normal lactation, milk turned into cheese and yogurts, often mixed with sheep and/or cow. We have mainly extensive farms with manual milking or individual milking machines, and we have also 4 large farms. Here are some original pictures of the Romanian dairy water buffalo cows. In the upper right corner, you can see their specific behavior called wallowing behavior, where they roll or lie in the mud. We can go to the second. Throughout the domestication process of cattle, which occurred in the Near East around 9,000 years ago, the initial aim of selection was tameness, ability which is strongly correlated with the behavior activity. However, during the last century, the selection of cattle shifted towards genetic improvement of production traits such as milk yield, growth rates, and carcass attributes. In highly gregarious farm animals, such as cattle and water buffalo, the social environment is an important determinant of their welfare and overall health fitness. It was shown that some large domestic ruminants are able to make sophisticated discrimination between conspecific and humans, possess emotional contagion, and have distinct personalities while exhibiting dimension of social complexity such as social learning. In both dairy cattle and water buffalo cows, temperament-related traits have animal welfare and economic implication, given that animals with appropriate temperaments grow faster, are easier to handle, transport, and fed, and can have superior meat quality. Moreover, reactive animals can threaten the safety of their contemporaries and of the animal caretakers. In cattle, behavioral activity is defined as an animal response to human handling, force movement, or response to a novel or challenging environment. Stress negatively influences milk production, with highly reactive nervous dairy cattle having higher cortisol levels and endogenous opioids in plasma, reduced oxytocin concentration, and increased heart rates during milking. Previous investigation outlined that a calm response to the entire milking procedure in dairy cows, it's important to maximize both the efficiency of the milking process and to minimize the residual milk volume. Moreover, in horse and Friesian derived breeds, milking temperament is generally regarded as a moderately heritable trait, with estimates ranging between 0.07 and 0.47. Milking temperament has been found to significantly influence the milking speed, conformation traits, other health, reproductive performance, and milk yield. Considering the implication that milking temperament has on milk yield in Australia and the Northern European countries, this trait was included in the estimated breeding value index of artificial insemination bulls for Holstein, Jersey, and Red Dairy cattle breeds. Lactating water buffalo cows are known to be more sensitive to handling during milking than dairy cows due to the fact that they were less intensively selected for milking traits. Previous studies highlighted that pre-milking stimulation and avoidance of stress during milking are prerequisites for the alveolar milk fraction injection in buffalo cows, which represents up to 95% of their entire milk production. The milking temperament of dairy buffalo cows has been found to significantly influence the milk yield, fat yield, and somatic cells count. Furthermore, negative human-animal interaction during milking were shown to be strongly correlated with restless stepping and kicking in buffalo cows. Given that breeding and selection have failed to increase the milk ejection in buffaloes, most large farms use oxytocin injection to improve the milk letdown reflex. A previous study demonstrated that repeated injection of oxytocin interfered negatively with the normal milk secretory activity of the mammary epithelium while inhibiting the normal ejection reflex. Temperament consists of traits an individual is born with. It differs from personality, which is a combination of your temperament and life experience, although the two terms are often used interchangeably. Temperament is considered to be determined by your unique neurological characteristics, and unlike personality is more resistant to change. The point of consensus between various approaches is that consistency over time and across situation are the major distinguishing features of temperament and personality traits. It is important to highlight that consistent does not mean the trait value cannot change with age or environmental condition, but that differences between individuals are largely maintained. Behavioral activity is commonly assessed by visual scores that consider the frequency and intensity of animal movements, which subsequently reflect fear levels and responsiveness. Subjective scoring systems are commonly used in the cattle literature to approximate arousal level during restraint and are recorded during routine management events in the scale or skews shoot. Temperament scores may be used to surmise performance parameters, handling ease, and response to stressful human-animal interaction. Throughout the typical production cycle, dairy cows and water buffalo cows are facing a series of stressful challenges such as separation from calf, frequent regroupings, isolation from herd mates for insemination, gestation checkups, housing in sickness pens, drying off. Precision livestock farming technologies have been profoundly integrated with farming during the last decade in order to monitor production and reproduction levels, as well as to detect health problems in dairy cattle. As a consequence, the use of infrared thermography to improve health monitoring and early detection of disease in cattle has gained a lot of interest. Limited research has been undertaken to validate the use of non-invasive tools such as infrared thermography measures for assessing social stress response of adult cattle, especially under typical commercial setting and contexts. There are several temperament tests used in cattle. In this PhD, we assessed temperament with three tests, namely the milking temperament test, the crush test, and the social isolation test. A brief overview of my PhD entitled Research on the Effects of Behavioral Activity on Production Outputs, Reproduction Efficiency, and Welfare in Cattle. The overall aim was to evaluate the effects of behavioral activity on animal-based indicators in dairy and water buffalo cows in order to improve animal welfare and future selection schemes. More specifically, the hypothesis was that calmer and less excitable cows outperformed the more reactive and nervous counterparts when milk yield attributes and reproduction outputs are concerned. We assess the temperament using different scales. For example, we assess the milking temperament using a 5-point subjective scale previously described and validated by other authors in increments of 1, from score 1, a calm response to the entire milking procedure, to score 5, a nervous response to the entire milking procedure. The same scale was then adapted for the buffalo cows. Another scale that we use was the 0-2 scales, also for the milking temperament. This scoring was based on descriptive definition concerning the cow's hind legs kicks in response to the milking procedures at 3 distinct stages of milking as follows: during udder preparation, at the moment of attaching the milking machine, and during the actual milking process. The shoot score and the exit score were evaluated using 2 different 4-point subjective scales, with each cow being restrained for 1 minute in a shoot and analyzing each animal's manner of exiting, reflecting various levels of excitement during the exit phase. We took into account different indicators such as productive and milk quality indicators, for example, milk yield, milking speed, fat content, etc. For the reproductive indicators, number of the artificial insemination per gestation, age at first calving, dry period length. For the welfare indicators, we assess the body condition score, mainly the welfare quality assessment protocol, as well as blood cortisol levels and infrared thermography data. For health indicators, we looked at the incidence of mastitis and somatic cell count, incidence of retained placenta, tarsal joint lesions, etc. My first study, effects of milking temperament of dairy cows on production and reproduction efficiency under tie stall housing. The overall aim of this study was to evaluate the effects that milking temperament has on production and reproduction efficiency and welfare of dairy cows housed in tight extension barns. Milking temperament of 91 cows was evaluated by 2 independent observers using the 5-point subjective scales. The cows were milked in the barn with individual milking machines. Based on the milking temperament scores, given cows were classified as either calm scores 1, 2, and 3, or nervous scores 4 and 5. We took into account 17 parameters per cow. The behavioral activity of the cow significantly influenced the milk yield, with calmer cows having higher milk yields when compared to their nervous counterparts. The relationship between the behavioral activity and the body condition score were significant, with calm cows having higher fat deposits and maintaining a better condition throughout the entire lactation. No significant differences for reproductive indicators, also for welfare indicators. Current results regarding the influence of temperament are in accordance with other previously reported, outlining that calmer animals have better milk yields. On the contrary, some studies found no correlation between temperament scores and milk yields in Holstein and Jersey cows. The reported differences are most likely due to the difference in general animal management and the level of exposure to humans. Moreover, these current findings have economic implication given that calmer cows produce on average more than 700 kilograms more milk compared to their nervous counterparts. Considering the average price of 1 kilo of milk, this infers an economic loss of more than 200 euro per cow per normal lactation if selection for calmer temperaments is not taken into account in commercial dairy farming. An unpredictable pattern was observed for the body condition score. The relationship between body condition score and temperament was significant, with calmer cows having higher fat deposits compared to the nervous animal, divergent from reports by other authors, which found body condition score as a reliable tool for energy balance and body tissue mobilization assessment in dairy cattle, and for the body condition score to have a strong negative genetic correlation with the milk yield. Such differences might be attributed to a higher feeding efficiency in calmer cows, as previously described by other authors. My second study, water buffalo responsiveness during milking, implication for production outputs, reproduction fitness, and animal welfare. The overall objective of this study was to evaluate the effects of the milking temperament of water buffaloes on milking traits, animal-based welfare indicators, and reproductive performance. Milking temperament of 60 multiparous buffalo cows at the beginning of their lactation, housed in tie stanchion barns, was evaluated by two independent observers using the same subjective scale. The cows were milked in the barn using individual milking machines. Buffalo cows were classified as either calm or nervous. 17 parameters per cow were taken into account. The behavioral activity influenced the milk yield and milking speed, with calmer cows outperforming their nervous counterparts, higher milk yields and faster milking ejection rates for calm cows compared to their nervous counterparts. No significant differences for reproductive and welfare indicators. The linear regression model for the dependency between milk yield and milking speed showed that for nervous cows, the dependency of milk yield on milking speed is considerably steeper, with lower milk ejection speed for nervous animals. No significant difference between the nasal and ocular infrared thermography temperature between calm and nervous animals between pre and post milking. However, we observe a slight decrease in calm animals for both thermal windows nasal and orbital after milking, post-milking. As for nervous animals, we observe an increase of the temperature in both thermal windows for both post-milkings. We can assess behavior during milking as an alternative for the oxytocin injection administration. The responsiveness of buffalo cows during milking and subsequently the effects of milking temperament on milk yield during the first 100 days of lactation are consistent with previous reports, where docile buffalo cows had higher milk yields when compared to their nervous counterparts. The milking speed was influenced by the behavioral activity of the buffalo cows in our study, with similar results being reported for the species. Contrary to our results on calving interval and ages first calving duration, previously published articles reported shorter intervals for both parameters. However, it is worth mentioning that they evaluated reproduction of water buffaloes under different climatic regions, significantly warmer than those found in our study, with the Romanian buffalo being mainly reared under highland condition of the Carpathian Mountains, which is expected to negatively influence both age and at sexual maturity of heifers and resumption of a new estrus cycle after calving. My third PhD study, infrared thermography as a non-invasive method for evaluating stress in lactating dairy cows during isolation challenges. The overall objective of this study was to evaluate and test the feasibility of using infrared thermography as a non-invasive method for measuring stress signs in lactating dairy cows during short negative challenges, such as visual isolation from herd mates. 20 lactating multiparous dairy cows were isolated from the herd, visually isolated, for 4 hours post-milking. We took infrared thermography data from nasal and oral regions, 3 readings at the beginning, after 2 and 4 hours post-isolation. Infrared thermography data was taken using a FreeWarm Pro LT mobile camera. Temperature measuring points were the lacrimal carbuncle of the eye in the orbital region and at the nasal region, which were previously validated as thermal windows for cattle, with pictures being taken twice per animal per region from 1.8 meters distance following the manufacturer's recommendations. In this table, we can see that there was a significant difference between the temperature at the beginning of the trial and after 2 hours post-isolation. Here we can see box plots of both nasal and eye temperature in the 3 times interval. We can observe an increase of the temperature both in the nasal and in eye temperature, and a decrease at the end of the trial. The infrared thermography approach is sensitive enough to be used for measuring stress in dairy cattle. Cows are significantly more stressed during the first 2 hours post-isolation. Overall, current results are in accordance with previous study, which validated both eye and nasal regions as infrared thermography thermal windows for studying the effects on painful and negative contexts on stress response in farm ruminants, while considering the stress-induced hyperthermia as an integral part of the physiological response to negative stimuli, as well as the current limitation that this tool faces. Contrary to our findings, other authors found that nasal infrared thermography temperatures to decrease in both positive and negative situation in cattle. However, these authors use mild positive, like feed anticipation, and negative feed-related context, receiving low-quality fodder, while in this current study, the cows were faced with a putatively more aversive challenge. Future research is needed on a higher number of animals for validation, including as well more age groups. My fourth PhD study investigating dynamics of behavioral activity in dairy cattle using shoot and exit score tests. The aim of this study was to determine whether cow's temperament remains stable over time, testing the reliability of the subjective measurements, and investigating habituation to handling in adult cattle. Our hypothesis was that temperamental cattle acclimate more substantially to repeated handling. 64 lactating multiparous cows temperament tests, shoot score and exit score, were undertaken by a single observer or over 2 distinct years. The shoot score was assessed using a 4-point subjective scales from score 1, a calm response, to 4, extremely reactive, in increments of 1, with each cow being restrained for 1 minute in a patura shoot. The exit score was evaluated subsequent to the shoot score and analyzing each animal's manner of exciting. The scoring system ranged from 1 to 4, reflecting various levels of excitement during the exit phase. Cows were classified as either calm, scores 1 and 2, or nervous, scores 3 and 4, while analyzing the results of the shoot score and exit score tests separately. The interclass correlation for the shoot score response was found to be poor and poor to moderate for the exit score response. The scoring dynamic for calm animals showed an increase of 0.37 points for shoot score response, and an extremely small estimate for exit score indicated limited to no practical change in scores over time. For nervous animals, the scoring dynamic showed a decrease in score of minus 1.19 points for shoot score and minus 1.30 points for exit score response. The evidence from this preliminary pilot studies show that nervous animals exhibit a more pronounced decrease in scores over time, suggesting that temperamental cattle and those handled more frequently habituate the most. More research is needed in order to validate shoot and exit score as indicator of dairy cattle temperament. While conventionally accepted, this test may not solely reflect innate traits being caused by contextual responses as well. This broader perspective encourages future research to develop more nuanced temperament evaluation tools, incorporating objective measures such as cortisol levels to foster comprehensive insight into dairy cattle management practices. Some ongoing studies. We already assessed the milking temperament of 149 Simontal Duer proposed cows with the same scale, the 5-point subjective scales. Based on the milking temperament, cows were classified as either calm or nervous. Cows were milked in the parlor. 14 parameters per cow were taken into account. And now we are working to find the genes that are implicated are connected somehow with the behavioral activity. Within some association studies between single nucleotide polymorphism and milking temperament using competitive allele-specific PCR. My sixth PhD ongoing study, Meschendorf Farm, we assessed the milking temperament of 200 dairy buffalo cows. Cows were milked in the milking parlor. The farmers told us that the buffalo cows destroyed already 2 milking parlors. For those animals with high milking temperament score, culling was the only option. I was fortunate to spend 8 months of my PhD at the University of Wisconsin-Madison with a Fulbright scholarship, and there we assessed the milking temperament at Plain Dairy Experimental Farm twice, on 6th of May and 20th of May for 463 American Holstein cows. 7 parameters per cow were taken into account. Each animal was assessed by 2 independent observers located in the main alley of the milking parlor during milking using a temperament scoring system with a scale from 0 to 2. This scoring was based on descriptive definition concerning the cow's hind leg kicks in response to the milking procedure at 3 distinct stages of milking, during udder preparation, at the moment of attaching the milking machine, and during the actual milking process. During my PhD, I was involved in a project called the Bovine Talk Project, which funded almost all my publication and my research stays abroad. The overall aim of this project was to investigate wherever vocal communication in cattle and water buffaloes linked with other physiological and behavioral responses can be indicative of well-being or stress, and whenever this indicator could ultimately be used as a tool for assessing objectively the animal welfare. Using a split plot over time experimental design, vocalization recordings, infrared thermography, accelerometer data, stress biomarkers and behavior were used to assess emotion and stress levels of cattle and water buffalo cows. I will present just the first trial. Our research question was, is frustration buildup modulating the vocal parameters in dairy cows? 20 lactating multifarious dairy cows were visually isolated from the herd for 4 hours post-milking. We obtained 4 hours of vocal parameters recordings per each cow. I gained some hands-on experience on hardware and software at the INRAIS Institute in France, Rennes, and at the end of the trial, we collected more than 1,000 vocalization. So cattle have 2 distinct calls, the low frequency calls in the left side for positive situation, the high frequency calls found in negative situation. I'm not an expert in machine learning, but through a collaboration with Haifa University from Israel, We developed two types of AI models to classify the high and low frequency calls and for individual cow identification. The models reach out more than 87% for the classification of the cow calls and 68% and 72% respectively for the individual cow calls recognition. Through our experiments using explainable and deep learning models, we have demonstrated the effectiveness of these models in classifying high and low frequency calls, as well as for identifying individual calls based on their vocalization. These results highlighted the future potential of vocalization analysis as a valuable tool for assessing the emotional balance of cows and for providing new insights into promoting precision livestock farming practices. Thank you for your attention, and now I'm open to any question. Thank you.
Thank you so much, Madalina. You did quite a lot in your PhD, so that's quite impressive. And there's many questions already coming in, which is wonderful.
Yes.
And if others have questions as well, please just type them into the chat box. So Birta asked, apologies for the non-behavior question, but what caused the reduction in the national herd of buffaloes from 600,000 to 18,000?
Okay, so as already stated, we have predominantly small scale farming. So it's kind of hard with dairy animals. So people weren't interested to raise buffalo cows. They're like not economically worthy, let's say. Unfortunately.
So they were very popular, and then people realized how
Yes.
much effort they were and said no, thank you. Okay.
Yes, indeed. It is very hard to raise a water buffalo cows.
I imagine so, just seeing their horns.
Yes, they are huge animals, so kind of difficult.
The next question is from Marwa. What are the parameters used to assess the animal temperament? And I think you've described them, but maybe give a quick overview again.
Yeah, so we assess the workability traits, meaning the milking temperament, with a subjective scale of one in increments of one from score 1, a calm response to the entire milking procedure, to score 5, a nervous response to the entire milking procedure. Then we divided the animals within calm and nervous animals, as previously done by other authors, and we compared the production outputs, the reproduction indicators, and the welfare indicators through the groups. And we managed to find that in the same housing system, the same diet, the same nutrition, the same animal caretakers, there are some differences in some indicators. Hopefully I respond.
Yeah, that was a great overview. And Mara has since given a bit more background that they're a PhD student working on dairy camels. So do you think there's anything from your experience with the dairy cows, dual purpose breeds, and water buffalo for these temperament traits that could be translated to dairy camels?
I have to come back with this. I don't have any idea. I'm working only with dairy cows and water buffalo cows, so I don't have any idea about camels. Sorry for this.
But maybe your study from Wisconsin comes to mind of the two observers looking to see how the cows were kicking when the milking machine was put on. So maybe that could be a measure that somebody's
yes, could be,
milking
but
camels.
yes, indeed, but I don't know how can we observe the camels. Yeah, it will be possible, but kind of hard, let's say.
Yeah.
A lot of practice.
Marwa, if you have other thoughts, feel free to type them into the chat. Another question from Birta. In the fourth study you presented, why did you expect more temperamental cattle to acclimatize more? Was it because there was simply more reactivity to temper or reduced?
Yes, interesting point. So I spend a lot of time in the farms, so I managed to see very reactive animals, let's say September this year, and within the next year, the same animal had a different temperament. So I was starting to realize that some changed within their behavior activity, maybe habituation, maybe I don't know. There is a syndrome called the learned helplessness behaviors or the giving up syndrome. Maybe when they are facing a negative situation, such as winning in the platform, or I don't know, I think they are giving up. So yeah, hopefully I respond to this one.
No, that's a great answer. Did you notice that there was any change in the farm staff when you went back?
No,
No,
the same
same
animal
staff.
caretaker, the same staff. We don't change our uh, people
Okay,
that
so
often.
very much the animals were changing.
Yes.
Interesting. I have a
But
question
not,
about,
sorry for interrupting, but not otherwise. So calm animals remained calm over time.
so it was just the temperamental animals.
Yes.
Yeah, interesting. For your in isolation study, why do you think that those first 2 hours of isolation were the most stressful? Do you think the cows kind of give up after 2 hours? That kind of goes
Yes,
towards your
it's the
blind
same.
helplessness.
Yes, I think
Yeah,
it's the same syndrome that I was talking about. Doesn't mean that after 2 hours the cows are happy, just giving up their behavior. Like I'm in a stressful situation and that's it. I wanna
yeah.
give up.
I've given all my energy and now I'm just gonna lie down or
Yes.
something. Yeah, okay. Birte asks, what is the biggest difference in behavior between dairy and buffalo cows? Is it mainly the temperament?
Yes, as I already stated, the domestication process for buffalo cows started way later than for dairy cows. So, yeah, and a specific difference between the two species is that for buffalo cows, there is a strong bond between the dam and the calf. So, for example, in some Romanian farms, they cannot milk the buffalo cows without the calf. So the milk letdown reflex is not available, let's say, without the calf. So the bond between the dam and the calf is greater than in dairy cows.
Okay, so they bring the calves into the milking parlor?
Yes,
Yeah, yeah, makes things complicated, I'm sure.
yes, that's why it's a decreasing number in our country.
Yeah, but a follow-up thought to that, there seems to be more and more interest in cow-calf contact. Have you
Yes.
seen anything that works really well with the water buffalo that you think that dairy farmers who want to do cow-calf contact in the future might consider?
So, related to this, I am fortunate enough to be part of a new Horizon 2020 project called Transform DairyNet. So, they will, I don't know, they will create some guidelines on the CCC thing. So, I, in the near future, we think that we can raise dairy species uh, in uh, in um, in cow-calf contact. I don't know for now.
Well, they're very lucky to have you on board.
Thank
You
you.
can at least
Thank you.
say what not to do from what you've seen with the water buffalo.
Thank you.
Anna says you said you spent 1 minute per animal to evaluate the shoot score. Why that amount of time, considering that behavior changes as time continues? I have the experience that animals start to calm down after 10 seconds in the shoot. Any thoughts?
Yes. Yes, I followed the Temple Grandin recommendation. So she assessed back in 22, I think, the shoot score. And I remember saying, she said that 1 minute of restraint
Yeah.
is okay to use. I don't know, maybe Anna or who asked the question. It's a very interesting suggestion. I can like develop further study with shorter intervals of restraining.
Yeah, and probably better for following the 3 Rs of reducing
Yes,
stress for animals.
yes,
Yeah.
exactly.
And there's the comment and from Marwa, I won't read it, but just everyone, this presentation is being recorded and it will be available on YouTube for you all. Elizabeth asks, did you notice any patterns in the social order of the cows that related to their temperament? And did more reactive cows tend to enter the parlor at the same time? Or do you think one nervous cow increased the reactiveness of others, or maybe even the whole group?
Yes, very interesting point. Actually, at the University of Wisconsin Madison, I noted this because the animal caretakers were like pushing the animals in different pens, and I observed some animals pushing others, trying to make a way to be the first one. But all the milking parlor was noted with some specific numbers. So I have the numbers. It's an ongoing trial, and maybe my supervisor from there will agree to do a connection between the order of the cows entering the milking parlor, and maybe those are the one more reactive than the others, or maybe not.
Yeah, great.
And for the study that I've conducted in Romania, unfortunately, we have the cows were milked in the barn with individual milking machines. So the order is not quite.
Yeah, they couldn't exert an order.
Yeah.
Yeah. There's 2 questions relating to previous experience, so I'll try to put them together. One
Yes.
is, did you test the effect of previous experience in your trials? But also, what about the differences perhaps between heifers and mature cows in temperament tests?
Yeah, so we excluded from all our experience the first parity cows, the primiparous cows.
Mhm.
And what was the question again?
The
The
previous experience. So, did you test any cows multiple times? Which I think you said that
Yes,
a bit
I
earlier.
did.
Yeah.
Yes, I did one-time assessments, two-time assessments at short intervals, and two-time assessments at a longer interval. We are like analyzing the data now, but somehow the scores are quite stable over time, and they were like authors that other authors related that milking temperament especially, is quite stable over time. So one-time assessment could be, I don't know, useful, and of course, it's widely used.
Yeah. And then a bit about the story of the cows. Are all the cows related? So, for example, were they all the daughters of the same bull, or was they were all quite different?
No, they were quite different bulls,
Yeah.
Holstein bulls, let's say. So we are now with the study of the Simmental strain. We are trying to collect some data from the genitors and somehow to connect the genes that are related with the behavior with the bulls. But there were daughters of different bulls. But selection for temperament is not included in the selection indexes of AI bulls that are in Romania. So no previous selection for temperament was done in the farm that I assessed the temperament.
Okay, so we can't really talk about any father effect.
No, I
But
didn't look at
yeah,
this. It would be interesting to see if some daughters are somehow more reactive or more docile.
yeah. It's amazing how you have a research question and then all of a sudden you have 50 other research questions just from the one. You can continue building forever and ever. But you bring up the Simmental cows, and I was surprised by the number that you said that 50% of your cattle in Romania are dual purpose. Could you
Yes.
describe that a bit? And I'm especially thinking of the calves. Do they keep the dual purpose calves on farm and raise them up for beef, or do they send the calves off to a different farm? What can you explain a little bit of what that
Yes,
system looks like?
of course. The Simmental strain in our country is called a dual purpose, but actually it's working like a Holstein. So it's
Okay.
mainly bred for milk, not for meat, but with lower milk yields than
Yeah.
Holstein,
Okay. But is there
but
any,
somehow more resistant I don't know, to disease.
yeah, yeah. Do you see any preference for a Simmental calf versus a Holstein calf for becoming a meat animal?
Yes, I think Simmental calf is winning.
Yeah.
So yeah, I don't know anyone who is eating Holstein
Okay.
calves. It's not a common thing in
Yes.
Romania.
Yeah. Okay.
We have Angus. We have some farms
Of
that
course.
are
Yeah.
raising Angus.
Yeah. Thanks for that. Anna asks, and this is going again back to the genetics and family situation.
Yes.
Did you find any relationship between docility and mothering ability or protection? So when the calves were weaned, did you do any tests then, or all the calves were already long separated when you did your behavioral tests?
No, I didn't assess this. I'm planning to calculate the heritability through
Ah,
our farms to observe the cow from the beginning day zero to one entire cycle. But sorry, I didn't look at
no,
this
that takes
until
years to
now.
do.
Yes.
Yeah. Well, I don't see any further questions coming through. Do you have any last thoughts you want to share with the group?
No, thanks for being here. Is almost 10 p.m. in Romania, so it's kind of late, and I'm super honored to be able to present my work here with you today. Thank you, thank you.
Well, the thanks goes all to you, Madalina. That's a very late night, and you did such a beautiful job with your presentation and answers to the questions. So thank you very
Thank you.
much. Congratulations on such a big year, and thanks for sharing your knowledge.
Thank you very much.